Here we illustrate the basics of trunk routing and present some tips for the best results. Starting with a schematic with two connectors and the connections mapped one-to-one as may be required on a backplane bus, we translate the schematic to a PCB which displays the net connections to be routed. With the grid set to match the connector pin spacing, we have the snap to grid set at half grid. We now select the starting pads to be trunk routed using Control plus the left mouse button. From the menu bar, select Add, Trunk Route. We then right-click and check Route Connections at Trunk Start. Allow Pick Connections are both selected. You will see several options for track spacing available. Push tracks further apart, use gaps between start items, and define gaps between tracks. Here we select Use gaps between start items. When in position, click to place. Move the cursor towards the target pads. It is the midpoint between the trunk tracks that is being snapped to the grid. And if you wander off grid, the tracks will show where the tracks will be placed, which will look odd. But move the cursor back on grid and you will observe a sensible placement. As you approach the target pads, right-click and select Autocomplete, and your simple trunk route is completed. Press Escape to exit trunk routing. Next we illustrate a trunk route with a defined gap. Now we show using a smaller gap and offsetting the tracks towards the top of the connectors. If you place the tracks too close to the connectors, the space is inadequate to route all the tracks. Use Undo and place the tracks further from the starting point. Continue to place tracks and then use Autocomplete. We now demonstrate a more complex scenario with double row connectors routed one-to-one. Translate the schematic to a PCB. Here the routing is complicated by the tracks having to pass through a row of pads. We start as normal, selecting our start pads and select trunk route. We start using the same track pitch as the connector pin pitch. As we route, you may see leftover track artifacts. Use function F5 to refresh the display. Also, as you route, the snap to grid may make odd track routing to try to place the tracks as the mouse pointer wanders off grid. But don't worry, as they will appear correct once the pointer is moved on grid. Use Autocomplete to get the required tracking. We next route the other row of connector pins. Because our initial tracks did not have the 45-degree segments in line, i.e. the same X value, it becomes slightly tricky to match the second row of tracks. However, it can be done as shown, but the result is not visually pleasing. Starting again, we now show some tips to achieve a good result. We start routing the first row of pins, and at a suitable point, with the ends of the tracks all in line, we select Finish Here. Next, select the destination row of pins and start routing. First, add in the 45-degree segment to pass through the row of connector pads. When close to the previously routed tracks, select Autocomplete. We now have a neat 45-degree segment joint. Repeat for the other row of pins and start routing. Use the zoom from the number keys to get a better view. Here we find our snap to grid is not correct to get a nice 45-degree transition, so we change the snap to grid to 1/4. We now have the tracks at the required position and select Finish Here. Route the tracks from the destination pads and zoom in. When close to where you wish to make the 45-degree segment to complete the tracks, select Autocomplete, and now we have a neatly routed bus. Now you know the basics, here are a couple of tips. In this video, we use the right-click context options for both Finish Here and Autocomplete. This process can be speeded up by changing the function of the double left mouse click. In Preferences, on the PCB Tracks tab, the double click can be set to Complete Track or Finish Here as preferred. When placing the trunk route, a white line is displayed. It is this that snaps to the grid. For an even number of tracks, this will be at the midpoint between two tracks, which is why we initially set the snap to grid at half grid.